Hello, welcome back to my channel. Today we will be looking at database normalization. Database normalization is the process of organizing the data in the database. Normalization splits a large table into smaller tables and defines relationships between them to increase the clarity in organizing data. Data quality is the key to success for any organization. Poor table construction can cause inaccurate analysis, misleading results, and poor decision making. If you don't have good data, you are essentially flying blind. Before you know it, productivity takes a hit, systems fail, and cost starts to increase. Redundant data leads to wasted storage space and increases the risk of inconsistencies and errors in the database. Normalization helps remove redundant data by organizing it efficiently across multiple tables. Normalization reduces the likelihood of anomalies such as insertion, updation, and deletion. This ensures that data remains accurate and consistent throughout its life cycle. By structuring the database according to normalization principles, we can ensure that updates to the data are made in one place, preventing inconsistencies that can arise from duplicate or conflicting information. Normalized database schema is easier to maintain and modify. It simplifies the process of adding, updating, deleting data without causing unintended side effects on other parts of database. What are database anomalies? Data anomalies refer to the inconsistencies or errors that occur when you deal with stored data. These anomalies can compromise the integrity of the data and cause inaccuracies that do not reflect the real world scenario. Let us see this with an example. The table that you can see on the screen is a form of unstructured table or a zero normalization form. Here you can see that the product table has various columns like product, usage, category, manufacturer name, and much more. But you can see for category here there are two categories, men and women. Similarly, for color, the shoes are available in three colors: black, white, and red. In database, anomalies are typically because of redundant or poor table construction. Anomalies can significantly impact the consistency and integrity of the data. They can cause inaccurate analysis, misleading results, and poor decision making. Therefore, it is a crucial step in any data-driven process. Primarily, there are three types of anomalies. Insertion anomalies. These occur when the addition of new data to the database is hindered because of the absence of other necessary data. This situation often arises in systems where specific dependencies between data elements exist. For example, if I were to execute the query like insert into product table category stock values men 2000, here I will get the insert. Update anomalies. These type of anomalies happen when modifications to the data end up causing inconsistencies. These usually occur when the same piece of data is stored in multiple locations and changes aren't reflected uniformly across all instances. Update product table set price is equal to 10,000 where category is equal to men. Deletion anomalies. You encounter these anomalies when you unintentionally lose other valuable information while removing certain data. This typically happens when multiple pieces of information are stored together and the deletion of one affects the others. As an SQL developer, you often work with enormous amounts of data stored in different tables that are present inside the multiple databases. Using normalization, you can solve the problem of data redundancy and organizing the data using different forms. This tutorial topics. What is normalization in SQL? First normal form, second normal form, third normal form, Boyce code normal form, fourth normal form, and fifth normal form. Let us see an example of first normal form. For a database to be in the first normal form, each field needs to have a atomic value. Atomic value is basically a single value, and each row needs to have a primary key. A primary key is a unique identifier assigned to each record within a database table, such as a driving license or a telephone number or Aadhaar card number. A relational database must have only one primary key, and every row of the data must have a primary key, and none of for a database to be in the third normal form, it cannot have transitive functional dependency. A transitive functional dependency means that every attribute that is not a primary key is dependent on only the primary key of that particular table. For example, in the category table, the category is fully dependent on the category code. In the color table, the color is fully dependent on the color number. Similarly, for the product, usage, price, manufacturer ID, category code is totally dependent on the product ID. But here you can see that the in the manufacturer details table, the pin code is dependent on the manufacturer ID, but the city is not dependent on the ID, but it is dependent on the pin code, because pin code decides the city. Similarly, for country is not directly dependent on the ID, but is dependent on the pin code, which is the primary key for the manufacturer address details. Let us have a look at 3.5 normal form, or the Boyce code normal form. A database design will meet the BCNF if all redundant base data or function dependency has been removed. For example, here you can say a table is commonly shared between two tables, that is the vendor table and the manufacturer details table. Here you can see that the royalty code, which is the primary key of the royalty details, is taken as a foreign key in both the tables. This reduces the data redundancy basically. Fourth normal form. Tables cannot have multi-valued dependencies on a primary key. There are no trivial or multi-valued dependencies other than the candidate key. This means that any dependency between the columns in the table involves a column that could be the primary key. Fifth normal form. A composite key shouldn't have any cyclic dependencies. For example, I have taken a subject, lecturer and semester table. Here you can see that the computer subject is taught by two lecturer in the first semester. Similarly, math is taught by John and Akash in semester 1 and 2. So here let us decompose the table for further better understanding. Here you can see that there is subject lecturer table, there's subject semester table and semester lecturer table. Here you will see that these are all cyclically dependent on each other. This is not allowed in the normalization. So that's it for today, and I hope you enjoyed. Please do like and share, subscribe. Thank you.